Hello everyone. In this GIS lecture video, I want to talk about another way that we can measure the center of the data. So in the previous video, we talked about the mean, which is extremely important, especially in relation to a lot of other calculations that we're going to be talking about later on. But there are other ways that we can measure the center of the data. And another very popular one is called the median. The median. And the way the median works is this is literally it's the number that is in the middle of the ordered data set. And I want to just quickly underline here the word ordered. I want to underline it 3 times because this ordered is very important, right? The mean, it didn't really care what order the data was in, but for the median, we really care about it being ordered. And what I mean by ordered is that the x values, what I mean is that the x values are sorted smallest to largest. And so the sort of way that we represent this mathematically is with the equation n plus 1 divided by 2 x sub n plus 1 divided by 2, right? And so hopefully you can see here that this is sub, right? So we had x sub I, right, where x was the value of the ith observation, right? In this case, it's x sub n plus 1 over 2, where n plus 1 over 2 that's the observation that we're going to look for. And this sort of equation here means that we're always going to take the middle value of the ordered data set. So you can already see here, right, dividing by 2, right? Well, what happens when the numerator is even versus what happens when the numerator is odd, right? What happens when we have an even number versus an odd number of observations? And there's going to be sort of a slight difference here. So let's talk about when we have an odd number of observations, right? Odd number of observations. So when we have an odd number of observations, let's go through an example. Let's say that you were to run a race 5 times, and you were to measure the time it took you to run that race in seconds. And the first time you ran it, you got 30.3 seconds. The second time you ran it, you got 35.1 seconds. The third time you ran it, you got 32.3 seconds. The fourth time you ran it, you got, say, 40 seconds because you were getting tired. And the final time you ran it, you put a lot of effort into it, and you got 29.3 seconds, okay? So these are 5 times that you ran a race. It's an odd number of observations. So how do we calculate the median? The first thing we do is we have to order the data set, which means sort the x values from smallest to largest. So we need to do some rearranging here. So sort data set. Right, so 29.3 is the smallest, then 30.3, then 32.3, then 35.1, and then 40. All right, and you'll notice here that we're not, in this instance, right, we're not necessarily tracking any observation number. We've just reordered the data set now so that observation 1 is the smallest and observation 5 is the largest. Okay. So now we have to calculate this n plus 1 over 2. All right, so n plus 1 over 2 is going to be equal to, n is the number of observations, so that's going to be 5 plus 1 over 2, because we have 5 observations. That's going to be equal to 6 over 2, which is going to be equal to 3. So our median here is going to be the third value in the ordered data set. So now we're going to go back to our data set and we're going to go value 1, value 2, value 3. Right, so in this case, right, this right here is our median. Okay, hopefully that made sense. So let's scroll down for a second here. And let's assume that you ran a 6th race. So you got these 5. Let's assume that you ran a 6th. So now you have an even number. Of observations. And let's just say you ran the 6th race and you just done you gave it your all in the 5th one, and so for the 6th one you're really tired, and so you actually take the longest that you've taken. So let's go ahead and copy down the ordered data set we have from before. Okay, and let's just say that you're really tired and you actually take 42.5 seconds to run that last race. Now, we're still in order because the last race was the slowest. So this is still an ordered data set, which is what we need. So let's go ahead and let's now figure out what observation we take for the median. All right, it's n plus 1 over 2, which means we have, in this case, now we have 6 observations plus 1 over 2. Means we now have 7 over 2, which means 3.5. Okay, so now you're going to go over here and go 1, 2, 3, 3.5. 3.5. Well, you can't go 3.5, right? There is no half observation here. So what you end up doing when the observations is even is you actually take the average of the two, right? Take the average of the two nearest observations. Right, and this is why it was important that we went ahead and learned the median first, because now what we have to do is we have to actually take the average of 32.3 plus 35.1 over 2, right? That's the average of these two numbers, right? So median is going to be the average, right? And if you do the math on that, right, 32.3 plus 35.1 divided by 2, you're going to get a median now of 33.7. Okay, so this right here, this is going to be your true median. And it's important, what's important here to remember is that the median does not always necessarily come directly from the data set. If you have an even number of observations, right, you're still doing a slight average. So hopefully that makes sense. If anything was confusing, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.